This year saw quite a few unfortunate game releases for the PC platform. With high-end PCs outright burning up in the CPU area and mid-range builds barely passing the minimum requirements, it has become challenging to build your future rig these days. The situation was somewhat similar 20 years ago, but we'll try to go back in time and build a mid-range solution that's suitable and is a bit more on the budget side. We'll see how it goes. If you watched our channel before, you may have noticed that we were gone for a while. There wasn't any particular reason for this. It was just a matter of time and the numerous issues we encountered on every single project we're currently working on. This particular project was filled to the brim with various blunders that resulted in it providing very little information we were set to acquire, but in doing so was educational in the areas we least expected. In the end, it was quite a wild ride. Anyway, as you can see, we're back. Let's take a look at the issues we encountered with our 2003 mid-range gaming PC build. We'll select parts for our project starting with the best price to performance CPU in 2003. The AMD Athlon XP 2500 Plus was a perfect choice. Clocked at 1.83 GHz and with 512 KB of L2 cache. Priced at around $100 or slightly above that outside the US, this CPU was one of the components that allowed us to blur the line between mid-range and budget gaming in 2003. We have two of these CPUs, which are both this exact model released in February 2003. To use it, we'll need a socket A, also known as socket 462 motherboard. Our choice is Asus A7V333-X, a motherboard that was released in 2002 and features the VIA KT333 chipset. The board supports up to 3GB of DDR1 and has 6 PCI slots and an AGP4X slot for graphics card. It also supports USB 2.0, which was extremely helpful for transferring data back and forth. The board was praised for its stability and performance at the time of its release. We'll place one of our CPUs into the socket immediately, to avoid damaging its pins. To cool it, we'll use the Spire cooler. No, not that one. This one. It's a basic socket A cooler, with a nice heavy aluminum heatsink and copper contact. Athlon XP CPUs were notorious for their high temperatures, and required adequate cooling to prevent overheating. We also add a case fan for additional cooling for other components. As for memory, we'll start with two Kingmax 256MB DDR1 sticks of RAM. They're 400 MHz because our motherboard couldn't support our particular slower sticks. However, they will work fine. We also have additional sticks, mostly 1GB ones, which we'll use as an upgrade. We'll place our motherboard on our homebrew test bench and secure it with a few screws. The Ati Radeon 9600 Pro is the mid-range champion graphics card we have chosen for this adventure. It features 128MB of DDR memory and has a core clock speed of 400 MHz. The card has 128-bit memory interface and mostly supports DirectX 9.0. It also has VGA, DVI and SVDO outputs. Tied or beating GeForce 5600 cards in performance, while being cheaper, this card was a clear win for ATI. Situated in the price range from $150 to $200, this card is the perfect choice for our build. This build marks the first time we'll try using spinning disks as our storage. Our choice is the Matrox Diamond Max Plus 8 40GB, released in 2003. It features an ATA133 interface and has a spindle speed of 7200 RPM. The drive has 2MB buffer and an average seek time of 9.3 milliseconds. It was considered reliable and its performance is decent. To mitigate its relatively small storage size, we have two of these available. Their health statuses are 98% and 93% respectively. In order to install Windows on this machine, we need a working compact disk drive. After testing several drives, we found that it's the best to use this DVD-RV drive via SATA IDE adapter. We cannot bring ourselves to burn any more disks, just for them to be sacrificed to the faulty compact disk drives. We'll use this small LC-powered 380W PSU. It's not from 2003. But it's our informed decision to use it instead of some old one. It's much safer to use newer and more reliable power supply units than to take chances with the older ones. The capacitors and other components inside PSUs have a limited lifetime, and you wouldn't want to risk damaging your old hardware by using an unreliable PSU. Just make sure that PSU supports all the necessary voltages, and any newer and reliable power supply unit should work just fine. Here's the complete list of parts we're going to use for this build. And here's the list of parts we'll try using as an upgrade. Let's see if our machine works. We got one beep, and we're inside the BIOS. The next thing to do is to install Windows XP, and you can see the sped up process here. And now it's time when various problems will enter the scene of our little play. The first sign of trouble was our capture setup not working. While it is very much wacky, it was working properly for every previous project. At one point, while in the process of setting up games and benchmarks, the system froze. After a reboot, this happened. Our system was broken, and no amount of tinkering brought it back. We've tried to install Windows XP on the other drive, but after a particular driver installed, the system just disappeared, nowhere to be seen. This is where we decided that we're going to use SSD via IDE SATA adapter instead of HDD for storage. We're used to getting a lot of flack for doing so, but it was either to do that or to give up on this project. This time at least we tried. Hopefully we get a better luck next time. The next problem we've encountered was the drivers for our Radeon 9600 Pro. If you were to download drivers for this card from the official site, you would download Catalyst Suite 10.2. If you were to install drivers from that package, prepare for plethora of graphical glitches and problems. We managed to find and install an older driver version 6.2, and everything worked fine. Running benchmarks was also painted red with problems. We couldn't even install every game in benchmark. We lost Fear and Crysis from our suite of games. The other one was a tough sell, but it was still interesting to try it out. Let's take a look at the results of the ones we managed to complete. We'll start with Quake 3 Arena. Here, we just wanted to check if it works as expected. From the results you can see that it sure does. We tested gameplay instead of the built-in benchmark. We hit the engine cap here, but we'll make sure to remove it in the configuration file next time. Next is Grand Theft Auto 3. This machine achieves more than playable frame rate without any issues. However, we notice the texture loading is all over the place. The possible culprit is the amount of system memory. This is the first time we use this game as a benchmark, and we're yet to iron out the process. Our journey will now take us to Wardenfell, a large island in the glorious province of Morrowind. Here we get playable frame rates on low and medium resolutions and details. However, when we turn all dials to 11, our gameplay experience turns into a stutterfest. The results we got do not differ much from the ones we got from the 2002 high-end machine. Our newest addition to the game suite is Call of Duty, the patriarch to the well-known family of games. Its IV or Infinity Ward engine is based on ID Tech 3, also known as Quake 3 engine. Similar to Quake 3, we experienced great performance with our machine on all presets. Our next game is Far Cry, a 2004 FPS from Crysis creators, Crytek. Performance on low and medium presets were great and good respectively, but the performance on the very high preset was far from playable, it was more cryable. While crying in the corner that Crysis didn't work, here we can present 9600 Pro's results from our large Crysis GPU benchmark breakdown. You can find more information about that topic in a separate video we published last year. Here are the results from the synthetic benchmarks that we ran. Regarding useful data, we can end the presentation here. Firstly, Oblivion refused to run on Windows XP no matter what we tried. We also had issues with the drivers and XP for our intended graphics card upgrade, Ati Radeon HD 3650 AGP version. After installing Windows 7 and setting up the proper drivers, we experienced abysmal performance from our upgrade. We tried out our Ati Radeon HD 4650 AGP version card just to make sure, only to get similar results. These two represent some of the latest AGP cards, which are actually PCI Express cards with a conversion chip. As such, they are supposed to give us the strongest performance possible when placed in an AGP slot. We don't know what's up with these AGP cards, but they can be hard to set up properly with little to no performance gain to show. The usual suspect and quite an obvious one would be drivers, as they were known to be pain in the nether area. This warrants further investigation into the matter, but that's a whole other project by itself. Windows 7 was unstable on our machine, with constant freezes and application crashes. We've added more memory for a total of 2 GB and tinkered with drivers, but the problem persisted. We also tried the other CPU we had, and the problem was even worse, because this one seems to overheat as well. At a later point, we found some 333 MHz memory that our motherboard accepts, but it made no difference. We even tried to reinstall the operating system, but that didn't help either. With one of those freezes, we had to restart the machine and there was no OS to boot in. Same as that Windows XP HDD problem, we got the same thing with Windows 7 SSD. We do have a lot of experience with the Socket A platform and many of its pitfalls, but these issues are still voodoo to us. We almost didn't notice the marvelous spelling of Athlon that our PC reported as its CPU name. This motherboard came paired with an Athlon XP 2600+, so we assumed that a 2500+ would be fine. We completely forgot about the logic of PC part manufacturers to release higher numbered parts before the lower ones. As it stands, our motherboard is on BIOS version 1002, and we need version 1003 for our CPU. Naturally, we updated the BIOS, and exactly one issue got resolved. Now the CPU name is displayed properly. However, we still have crashes, freezes and general instability. The other CPU was now working more similarly to the first one, just with an extra issue of overheating as the hot cherry on top. Perhaps we could try some of the newer BIOS versions. Maybe there's something there we're not aware of. As I mentioned earlier, this was quite an adventure. Testing hardware that's 20 years old has its drawbacks since we can't know how it would behave when brand new. From our experience, Socket A motherboards tend to age poorly, which might be the cause of our numerous issues. Some of them we understood and resolved, some of them we caused and resolved, and some of them remain a mystery. Despite these issues, we were able to complete some benchmarks and gather useful data for future projects. As for the results, we're actually happy with the performance we got from the hypothetical price of the components. If we had owned such a machine back in the day, we would have been perfectly happy with it. Maybe we'll give this build one more chance and spend more time with it to make it show its full potential. This was an incredibly fun experience, even with all the issues. In fact, some of the issues were fun themselves, as they challenged everything we knew about this platform. For example, why does one of two identical working memory sticks work while the other doesn't? Why doesn't the BIOS battery seem to work? And where did our operating system go? Now, all we know is that we know nothing, so you shouldn't take anything we say at face value. We do this as a hobby and just for fun. Hopefully you had some fun too. You can expect to see us failing at more stuff in the coming months. See you around!